ARPSpoof is a tool that attackers typically use for ARP poisoning within an internal network. So let's say an attacker gains access to your internal network environment. He has run a discovery scan. He has a list of IP addresses. He has enumerated for open ports and is able to recognize the services that are running within your network. So the next thing he does is that he fires up ARPSpoof and then sends out forged ARP replies to all the devices on the network. It poisons their ARP cache. So when they're exchanging data within one another, their data is being routed through the attacker's network interface card. So the moment the attacker then turns on Wireshark and then listens on his own network interface card, he can see the information that is being exchanged between different parties. So now, this is the lab scenario I've set up for this presentation. So I have 3 devices within Evil Corp's local area network, right? So Evil Corp is the name of the company, and then we have an attacker within Evil Corp, right? So we have an internal web server here that is running on WordPress, and then we also have a Windows 10 machine also that belongs to the IT admin's PC. And then we also have Elliot, who is the attacker that has infiltrated their internal network. And now he's just trying to pivot from one machine to the other and then probably trying to find juicy information to exfiltrate and then go sell on the dark web and then make money. So now, once he has successfully poisoned the ARP cache of all of these devices, so the step 1 is that when the IT admin sends traffic destined to the web server, say a login attempt, it first goes through Elliot's laptop. And then from Elliot's laptop, he sets up port forwarding to the web server. So login credentials will be sent here. It lands on Elliot's laptop first. He's able to read it. And then once he's able to read it, he gets what he wants and then sends the request to the web server. And then the web server gets the requested page by IT admin, sends it through Elliot, and then Elliot forwards it to IT admin. So IT admin in his mind thinks he has logged in, not knowing that somebody has actually sniffed out his credentials. So I'm going to walk you through the process of how the attack was carried out. So the first thing that I'll be doing is that I'll first run a discovery scan to discover assets within the network environment, the local area network. And then the next step would be to enumerate. So attackers typically try to scan for open ports, find out what services are running, what services might be vulnerable, and then exploit that vulnerability, right? So when I find out the open ports and services, I'll move on to ARP cache poisoning using ARPSpoof. I would use ARPSpoof to poison the ARP cache of the web server and then the IT admin's laptop. So once I'm done with that, I would intercept and sniff out passwords with Wireshark. So I'll try to gain access to the website admin panel using Wireshark. And then once I'm able to achieve that, I can now log into the website's admin panel and then proceed to upload a web shell, which will give me backdoor remote access, right? So I'll upload a script that would be executed on the web server that will provide me remote access to that web server at any given time, right? And then moving on from there, you come to realize that, okay, you have limited privileges on the particular server or the particular target, right? So the next step you want to do is to now enumerate again to find privilege escalation vectors, to look for system misconfigurations, to find things that you can use to escalate your privilege to probably admin or root or system owner. Once you're able to achieve that, you have full control of that system. You literally own the system. You can now proceed to exfiltrating data. You can decide to take down that server. You can decide to just use the server as a pivot to other devices on the network. And then when an attacker is typically done with their intention, they delete or they carry out housekeeping, they clean up the scripts and files that were used for enumeration. Right. So I'll be doing all of this now. Then once I'm done with the initial attack, I'll put in security controls, and then I'll try to carry out the attack again, and then obviously it will fail because I have put in the security control against these types of attacks. So I'm going to be sharing my Kali screen. All right. Can everybody see my screen?
Yes, we can see your screen.
Yeah, I can see it.
Great. So I have virtual machines running within my VMware environment. I'm just emulating an internal network. So in this environment, I have the attacking machine, which is Kali Linux, and then I have a WordPress server that is running, right? And then finally, I have the IT admin's PC running Windows 10, right? So these are the three machines that I illustrated in the diagram, right? So this is the attacker's machine. Right, it takes a while to log in. Right, so this is the attacker's machine. As I stated in the procedure or the steps of exploiting the web server or gaining access through launching a man-in-the-middle attack and sniffing out traffic, the first thing I want to do is to discover assets on the network, right? So I am on the victim's network, and then I want to discover other assets, right? So one of the fastest and easiest way of doing that is using fping. Although you could run a ping sweep scan, that would take a little bit of time sorting out the data to know which hosts are live and which hosts are not. So first thing you want to do is fping. Okay, no, sorry. First, I need to know what network I'm on. Right, so this is my IP address, the internal IP address of the organization. The subnet max tells me that this is a /24 network, so it's a class C IP address, and then from there I'm able to now scan for hosts on my network. So the network I'm going to scan is the /24 network address. So I run fping. So now I put in the IP address. So I'll explain what each of these switches do when I'm done typing. Right, so the name of the tool I'm using is called fping. I've instructed it to scan all, and then G is to look out for hosts that are live, and then anyone that has an error, just send it here. So I don't get any error, it just shows me what hosts are live, and then that's it. So when I run that, I learned that there are 4 IP addresses. The first one definitely is the gateway. The second one, we are not sure what device it is. So let's assume I'm an attacker within an organization. I'm not sure what IP address or who owns the IP address. And then these two, I'm not sure who owns this IP address, but definitely I know that this last one is owned by me. So this is my own IP address as indicated here. So now I know that there are 2 hosts that are live on within this network. So we've done the first stage of discovery. Now the next thing is enumeration, right? I'll be using Nmap to scan for open ports and services to be able to differentiate which devices may actually be servers and which devices are just client machines. So as not to take a lot of our time, I'm going to run a fast scan. So it might not show the service version, but it will show the ports that are open and the ones that are closed. So the first device I want to scan is this. Let me set the time for. All right, so right away, the scan ran real quick in a matter of seconds. I have 3 open ports. Port 135 has, port 139 and 145 are for SMB. If this was Windows 7 and it's using SMB v1 and it's not packed for Eternal Blue, then I could easily exploit this to get into the Windows machine, but that's not the scope of this particular demo. The intention is to gain access to the web server. So now I can recognize that this is the Windows machine. You can actually see here, it says Microsoft DS. If I run a service scan, it will show me the operating system. If I run an operating system scan using the operating system switch, using Nmap, it will show me the operating system. And then the next thing you want to do is you want to run a scan on the next IP address, 92.168.72.139. All right, so from here, we can easily tell that this is a web server because of the ports that are open. So you have port 80 open on this device, and you also have port 443, right? So port 80 is for HTTP, then port 443 is for HTTPS, HTTP secure. And I also have port 22 open for SSH, right? An attacker can typically try to brute force the SSH port since it's open in order to gain remote access to this machine, but that also is outside the scope of this demo. Now, the next thing that I'm going to do is to poison the ARP cache of my targets, right? So the first thing I'll do is to check my own ARP cache using ARP-A. Right, so this is what I was saying about the ARP cache. So my device recognizes that the Windows host has this MAC address, and then the web server has this MAC address. So the next time I want to send information to any of this, maybe I want to ping the web server, it doesn't have to send out an ARP broadcast for the MAC address of those IP addresses. It just comes here, looks at the MAC address, and then sends information directly, right? So on the other devices too, they also have a list like this. The moment I poison their ARP cache, the ARP cache of the web server and the client, what the client will say is, it will show the IT admin's IP address, but the IP address will be mapped to the MAC address of my own machine. So this is what, if this doesn't show the MAC address. So it will show the MAC address of my own machine, right? So it will map the IP address of the IT admin PC to my own MAC address, and also on the web server, we'll have the IP address of the IT admin PC mapped to my own MAC address. So both of them will be sending information through my own network interface card, which I'll be listening on with Wireshark. So the next step is what I'll take. But before that, in order not to lead to a denial of service situation, we need to set up port forwarding, right? So I have written a script to enable port forwarding on this machine. So when it receives packets that is listening, that is being sent to it, it forwards it to the proper destination, right? So I've enabled port forwarding. And then the next thing I want to do is to poison the ARP cache of the targets. So the tool is called ARPSpoof. So if I do ARPSpoof H, it shows the usage of ARPSpoof. So you have ARPSpoof. The interface you want to listen on, that's your own MAC address of your network interface card. Then the target comes in here. So the targets would be the IT admin PC and the web server, right? So let me now show you what happens when I type this command in full. So the interface will be my Ethernet interface, which has the MAC address of the internet. Then my targets would be first the IT admin's PC, and then the web server's IP address. If you have any questions, you can just leave it in the chat section. We'll come back to it later. So now when I hit enter, it's sending out ARP replies randomly, right? So sending out an ARP reply to the web server that this is my MAC address, right? But then this MAC address belongs to me, and then the web server records it on its ARP cache and then forwards packets to me. So in order to make it a bidirectional situation, would have to also do the same thing for the IT admin PC. So run the same command. Right. So now both ways the ARP cache is being poisoned on both ends. So the next thing you want to do is to have Wireshark running. So I'll open Wireshark now. And so using the same interface I specified during the ARPSpoof in the ARPSpoof command, which was F0, I'm going to listen for traffic that is being exchanged through that wireless interface card, or through that network interface card rather. So I come all the way down, select the interface I want to listen on, and then I start capturing. Perfect. So now that we have this running, the next thing I want to do is to emulate a login scenario of the admin. So let's say the IT admin wants to log into the web server, probably to carry out administrative tasks. What I'm going to attempt to do now is to sniff out his login credentials from my device. So for this first instance, I'm going to use HTTP. Please kindly take note. Right, so it's redirecting me to HTTPS. Perfect. All right, so here I am. I'm going to log in using the admin credentials. Perfect. I'm logged in. Now I'll go back to my Wireshark to look out for the traffic that I just sent. So first thing you want to do is to stop the capture. And then next thing you want to do is to filter. So if you look here, you can see the source, destination, the protocol, the length, and information, right? So the source is where the information that is being sent has originated from, and then the destination is where the information that has been sent is destined to. And then we have the protocol that was used in transmitting this particular information, and then you have the length of the packet. So the size of the information that was sent is the length, and then information about the packets, like the particular IPv4 packet that was sent is contained here. Right, so you can see here that I do not own any of these addresses. This is the IP address of the web server. No, this is my own IP address rather. And then this is the IP address of .10, ICMP, that was a ping. I'm looking for where the two devices that I do not own communicated. But anyway, if once I filter it out, I just want to see this guy, right? So if you come here, you can see there was an exchange between the IT admin's PC, if you recall, .10 and .139, right? It's showing me all types of protocols, but what I'm interested in is HTTP, right? So I would come up here and then filter out that using just typing in HTTP here. It will only show me HTTP traffic. Perfect. Right, so from here, you can see that there was a GET request from the IT admin's PC that was sent to the web server. So it asked it to get the login page, the admin login page. Then once it received it received a 200 OK. A 200 OK was sent. Code 200 means that, okay, your request is valid, and then here goes the web page you requested for. So now the web server replies with a 200 OK to the IT admin's PC. That's when the page loaded. And then what happened next was that the IT admin tries to log in to the web server, right? So it sends a post request to the web server, right? When you follow this stream, you should be able to see what was exchanged. Perfect. So this post request that was sent to the web server from the IT admin's PC, the form login page had the login, which was admin, and then the password, case password 121, UG password 121. And by every standard, this password is kind of strong because it has uppercase, lowercase, and then special characters. And then it's more than 8 characters. So using these credentials, I'm going to log into the website, right? So from my attacking machine, first I need to just minimize this. So now let me try to log into the web server using the credentials that I sniffed out. Perfect. So admin, and then the password. Right. So now I'm able to log in as the admin, right? So this is probably like a stage 1 exploitation. This is like stage 1 exploitation, your initial access, right? So what could happen from here? Probably website defacement, and then nothing more, just stuff that kids can do to just gain fame and stuff. But a real cyber criminal wants to get money. Most of them want to get money. So how do they get money? They'll probably try to exfiltrate data and then sell it off, right? So the next thing that an attacker will typically want to do is to upload a web shell. The web shell will run a command that will provide me remote access to the web server. So I have direct access to the web server. I can see all of the things that are stored on the web server. If there's a database there, for people who have their database server and the web server installed on the same server, that's bad practice, because once your web server is compromised, your database is also compromised, right? So typically this is a hack, right? Every WordPress website, I believe every WordPress website, regardless of the version that's running, as long as you don't have a web application firewall installed on that web server, or even a firewall at all, this works on every WordPress website. Now, when I come to appearance and theme editor, I can see a couple of default pages and themes, right? On this left-hand side, you can see a couple of pages, PHP pages and all. Let me close Wireshark so my system doesn't freeze. Right, so I can see a couple of pages here. So what I'm going to do is I'm going to replace the code of one of these pages with a malicious script, which will be executed by the web server and will provide me remote access to the web server. But the first thing I want to do is to get my web shell. So I already have a web shell written in PHP. So let me open it and explain what's going on there. Right, so this is a PHP script. The main aspect of focus is the instruction of telling the script that, hey, connect to this IP address, which is going to be my IP address on this particular port, and then execute a shell, right? So when I upload this to the web server would connect to me. I'll be listening on this particular port, and I need to connect to me and then execute a shell, and then I have access to the web server. So I'm going to copy this out, and then I'll replace this code here with my malicious code. Updated the file, right? The next thing you want to do typically is to set up a listener using netcat. I'm listening on port 443 as indicated within the malicious code that I showed before. I'm going to minimize this a little. Right. I want you to see the instant I get a shell on the target. So now that I have that saved on this website 44.php, the moment I go to this page, it will return a shell here. So pay attention. So WP content, themes, and then 2019, and then 404.php. Right, so it executes, and then I get a shell. Right, so I have remote access to that server. So this particular shell is running as www data, which is quite limited, and I would like to elevate my privileges to system owner. But then before that, I would like to break out of this restricted shell. All right. Exactly. So I've broken out of the restricted shell, and then the next thing I want to do is to upload my enumeration scripts to this device. So what I typically use to transfer files to my targets is I set up a web server on my attacking machine, and then I use the target machine to download whatever I want to download to the target machine. So once I do ls, you can see I have a script named SUID finder. Because I was the one that created this lab environment, I know the security misconfiguration I enabled here. So just note, so we spend much time doing enumeration, I just wrote a script that would go for that particular vulnerability that exists on that web server. So the first thing I want to do is to set up a web server here. But 80. I spelled Python wrongly. Right, so I'm serving on port 80, and I'm able to download this file to the attacking machine. Right, so next thing you want to do is to go to the temp directory, because you can read, write, and execute in the temp directory. Now I use wget. Wget is a tool used to transfer files or used to download pages or download files. And then I put in my web server's IP address, my own attacking machine's web server. Right, so now I have successfully downloaded the script to the machine. I believe I had one here before. Anyway, I had one here before. I forgot to clean up after I exploited. So now what I'm basically doing is that I'm making this file executable. So by using this switch, I'm able to change this file to an executable file, and then now I can run it. So the next thing you do is to run it. All right, so let me briefly explain what I'm trying to do or what I'm trying to achieve. There are certain binaries that run on systems with privilege permission. So anybody can run that binary and use it to gain admin access. So let's say, for example, you have, I don't know, any exe file that is running, maybe chrome.exe is running as administrator. You know, sometimes you can decide to run a file as administrator. So imagine being able to set it permanently that anytime you run Chrome, let it run as administrator. An attacker who gains access to your system can use that to elevate his privileges to an admin user because of that security misconfigurations. So it is quite important for people, probably you're setting up a server, ensure that you don't have those files that would allow a non-privileged user to run as a privileged user, right? So if I view the permissions of all of these files, it will show that they have an SUID, a sticky bit key. So looking at all of these files, find is a binary, this is a binary, this is a binary, all of these are binaries, right? But find shouldn't have that permission because there's a website you can go to look for binaries that can be exploited to provide you privileged access, right? So when I go to tfobins.io, I am able to find binaries. So it's a list of binaries that can be exploited as an attacker to bypass local security restrictions, right? So all of these binaries can be used to bypass local security restrictions, probably give you break out of a shell, a restricted shell, or even provide you privileged access. So now if you recall, after I ran the scripts, I saw this particular binary. So if I search for find here, find comes up, and then once I open it, I can just see this, the command I'm supposed to run to give me root access. So the moment I run this command, if I copy this and then paste it on the web server, I immediately get root access on the web server. So if I run the command, who am I? It says I'm root, but initially I was this person, this user, www data, but now I have root access. I can go to any location on this particular server and do whatever I want to do. So let me exit first, right? And let me show you something. I want to go to the home directory without having privileged access. So these are all of the directories. And then this directory is owned by root. So it's only root that has permissions. If I do ls, if I list the directory, I can see the permissions of each directory. Let's just pay attention to these permissions here. So you have D means that it's a directory, that this is a directory. Then the first three refers to the permission of the owner, right? So it says that roots can read, roots can write, and roots can execute whatever within this directory. And then for the next three, it says the probably it's a group that the group users can read and execute, right? They can't write. And it says also for the last set of users, maybe non-privileged users, you can say it says you can only read, you can't write, but you can execute. So that is why if I try to go into this directory, because I don't have read access, it's only root that has read access here. Because I don't have read access, it's dummy permission denied. See, it says permission denied. But now, if I run that script again, the one I got from GTF opens, now I am root. If I try to go into the root directory, I now have permissions, right? See, it didn't stop me. So apparently root has a document. When I go into documents, let's see what's contained there. Perfect. Okay, so you have a file named client data.back. So if I copy out this data, I should be able to find juicy information. Perfect. All right, so apparently this file contains names of people, credit card information, email addresses, and then their home address. So this is sensitive data that's been exposed. An attacker can decide to exfiltrate this information, and when he exfiltrates it, he puts it up for sale on the dark web. And that is how you hear, oh, company XYZ got breached or company ABC got breached, because an attacker was able to exploit security misconfiguration, got access to where it was not supposed to get access to, and then probably exfiltrated information, and then it became very well known. All right, moving on. Now I've been able to show you how you can go from poisoning the ARP poisoning to gaining root access on the system. So now we would, I may not need to go through the entire process of cleaning up, but so typically as an attacker, you want to delete these files that you used. And then you want to also clear your logs, but I'll not be doing that. Right, so probably during investigation, cleared my tracks, but a very good forensics guy will be able to detect that that was what I used. But typical house cleaning involves that, or housekeeping involves that. So now I can like to exit. All right, so let's go on to mitigation and mitigating these types of attacks. Right, so I was able to show you how all of this happened. Right, I first carried out asset discovery. I enumerated, found the services running on each IP address, and then I poisoned the ARP cache, intercepted by sniffing out passwords, exploited the web server, escalated my privileges. Data exfiltration would involve me just copying the file to a writable directory and then downloading it to my target system. And then housekeeping was where I deleted the files that I used. So now let's go to best practices for mitigating man-in-the-middle attacks. So there is a number of things you can do, but for this context, in what I did, if say for example you have your wireless access point and then your password is weak, an attacker gains access to your enterprise environment, is able to listen on information that is being exchanged. That's an entry point. So you should also always try to implement strong wireless equivalent privacy and encryption on access points within your environment, and try to avoid the use of say something like WPA, all those outdated encryption algorithms, and also force the use of HTTPS. So you might look at it that it's an internal server. Nobody will try to attack us, or there's no need to be so rigid in implementing security, right? HTTPS just encrypts the traffic that is being sent between the clients and the server, right? So if you are able to implement HTTPS, which I'll be showing you what would happen if we had HTTPS within the environment, you're able to implement HTTPS, an attacker would not be able to read data that is being sent, because without HTTPS, it's being sent in clear text. But with HTTPS, you're encrypting that traffic, and then an attacker is unable to read it. Although there are tools you can use for sniffing out HTTPS traffic, tools like AirTag, this is for SSL stripping. But at least it's a measure, because in the case of man-in-the-middle attacks, it's more of preventing it than detecting. It's harder to detect than to prevent it. Also, you could also use a virtual private network, set up a tunnel, right? So information that's being exchanged between the host and the server is being tunneled through VPN. So an attacker can't listen on what is being sent or what is being exchanged, because it is obviously encrypted. And also, make sure you use strong router login credentials. I've seen a scenario of where some ISP guys came to come and set up an access point within an organization, and then they use the default password, right, of the router. So I was able to log into the router, change the router's passwords, and everybody did not have access to the internet because I was able to change the router's passwords. Or alternatively, an attacker typically wants to set up port forwarding. So when he sets up port forwarding, all of the traffic that is being sent to the router is forwarded to another IP address. So that's how to prevent. Those are some of the best practices in preventing man-in-the-middle attacks. Moving back, if you recall the types of man-in-the-middle attacks I illustrated, in the case of, say, like email hijacking, you can confirm, like probably you got an email from your boss, right? Confirm that it actually came from him before you decide to take action, especially when it involves things like money, right? You can like to confirm, double check, put a call across, and ensure that the information actually came from him. In the case of rogue wireless access points, right? You want to use a VPN, like I also stated. If you are using public Wi-Fi, make sure you use a VPN so that your traffic is not going to be sniffed by an attacker. So I'll just briefly run through the mitigation of man-in-the-middle attacks when it comes to ARP spoofing, right? So this time I am going to log out, and then instead of using HTTP, I'm going to be using HTTPS instead to log in, because the web server has port 443 open, which is for HTTPS. So I'm going to start listening again. Perfect. So now I have HTTPS. So I'll do HTTPS. Now it keeps going to Bing search. Right. So because it doesn't recognize the certificates, it just brings out the certificates error. Remember, I'm listening on the attacker's machine. So this time I'm going to log in again. Perfect. So now I'm logged in. Let's see what we have here. So now I'm going to stop capturing. And what I want to do is to filter out all traffic that's been testing for port 443. So this is information that has been transmitted between these two people. Anyway, if you look at application data, because application data is what contains what is being sent or what is being exchanged between the client and then the host. Sorry, between the client and the server, right? When I come down to application data, if I follow TCP stream, you notice that the information is scrambled. So I can't find login credentials from here. It obviously shows nothing, right? So that way you have taken a step towards preventing man-in-the-middle attacks through probably ARPSpoof or packet sniffing on your network. I'm trying to look for data between. All right. Okay. Yeah, I believe that would bring us to the end of the demo session. So if you have any questions, you can feel free to ask me. Thank you. Does anybody have any question? Okay.
Any question, anyone?
Hello, good afternoon. Please ask the question.
Okay.
I saw when you wanted to find the contents of the file and you used, is it BAK?
Yes.
Can you also use the CAT?
So BAK is a file format for backup. Most servers usually store backups using that particular file extension. So
Okay.
BAK is a file like you have TXT for text files. So BAK is typically used as a backup file format.
Okay, but can you also use CAT?
CAT?
Yeah.
Okay, to read out the contents of that file. Yes, you can use CAT, but
Okay.
because I really populated that file with a lot of data, so it's occupied the entire screen, I just put head to show the top part of that particular file, just maybe the first few lines.
Okay, thank you.
All right. All right.
Any other question, please?
Okay.
All right, cool. If there's no any other question, we just have to thank Toby for this wonderful presentation on ARP spoof ARP poisoning in terms of man-in-the-middle attack. And I think there's a disclaimer we should have made earlier on before the presentation, which I'm just going to quickly make on behalf of the Cybersecurity Association of Nigeria. That the presentation made today by Toby is for educational purpose only, and also for research purpose. We do not expect people to start, implementing man-in-the-middle attacks or doing unauthorized hacking. It is against the ethics and what Cybersecurity Association of Nigeria believe in and what we stand for. So in no circumstance will Session be liable for any unlawful use of the knowledge that you have gained today in this presentation or any damage whatsoever. arising from loss of data or profit as a result of you implementing man-in-the-middle attack against organization unlawfully. So I just need to state that clearly. So thank you all for attending today's presentation, and we're gonna, as promised, we're gonna publish this on our YouTube channel, and we encourage you to subscribe to that channel as well. So also in 2 weeks' time, we're gonna have another presentation. This time around, it might not be as technical as this for those of all you that are into governance, risk, and compliance. So we're gonna balance it up and come up with something in that direction. So thank you all, and have a wonderful day.
Thank you.
All right, thank you.
Thank you very much.